This is why transistors are dying. Who is Gordon Moore and what does this graph mean? Well, to start, we need to know what a transistor is and why it's the most important reason you're watching this video right now. All electronics are made of transistors, our phones, TVs, and even our headphones. If your phone is an entire Lego set, transistors are like small Lego blocks that are very distinct from each other. So how do transistors work? Let's imagine. Silicon has 4 electrons in its outermost shell, called valence electrons. These electrons play a crucial role in its electrical behavior. Silicon naturally forms a crystal lattice structure, creating a stable and predictable environment for electrons to move around. Silicon's properties can be modified by adding different molecules in doping. Doping introduces extra electrons or extra electron holes, which changes the conductivity of the silicon. One element, phosphorus, has 5 electrons in its outermost shell. When phosphorus bonds with silicon, the 5th free valence electron from phosphorus is free to move around, which makes the silicon n-type for negative. Another element, boron, has 3 electrons in its outermost shell. When boron bonds with silicon, the space leaves an electron hole, a location where electrons are missing. This hole is free to move around the structure, which makes the silicon p-type for positive. A typical transistor called an NPN transistor consists of 3 zones. 2 zones of n-type silicon on the side, and 1 zone of p-type in the middle. Positive and negative terminals, called the source and drain, are connected to the n-type silicon. A third terminal, called the gate, is connected to the p-type silicon. The area where the p-type and n-type silicon touch is called the depletion zone. Initially, to balance out the charge, the holes from the p-type and the extra electrons from the n-type cross over this barrier. When this happens, there are no more free charges available to move through the material, which prevents electrons from moving from the source to the drain. When voltage is run through the gate, the depletion zone is pushed down, and electrons can move freely through a tunnel from the source to the drain. Now, Moore's law is an observation by American engineer and businessman Gordon Moore, who noticed a pattern where every year the number of transistors in a circuit doubled. That's why the line on this graph is linear. Recently, however, you'll notice that the line is starting to flatten. The reason is that we made the p-type zone so small that it is no longer effective or reliable. The barrier that was meant to stop the electrons from crossing is too close to the other n-type zone, so electrons just pass the barrier. So,